ACT Science Tutoring Packet, Answer Key Part 1. There may only be one part, but I haven't done it yet, so let's talk about the ACT Science test. It's a reasoning test. It's really a reading test. A lot of people get lost on it. They think they need to know a ton about science. It doesn't hurt, but it's really not essential. There are 40 total questions. Once upon a time, there were 7 sections. Now they've changed it to 6 sections. It's extremely annoying. Once in a while, they'll actually have 7 sections, so they don't seem like they can keep their minds made up. Time's an issue. Time's an issue on this test almost more than any other one because it's the 4th test. You've got your English, your math, your reading, and your science test. It's the 4th one, and people are usually pretty worn out by then. So be aware that time is going to be an issue. There's 3 major types of passages. You got your data representation, charts and graphs. All of them can have charts and graphs, but usually the data representation is focused primarily on charts and graphs. Research summary, which really are experiments. We did this. We put these 2 chemicals together. We had a car, and we ran it down a sled, down a hill or something like that. Things like that. And then the last one is conflicting viewpoints, which is theory or fighting scientists. It's one of the longest passages, so if you're budgeting time and it takes you a minute longer than that, don't worry, you should be able to make up time somewhere else. So, not as big a deal. There's 4 main content areas: biology, chemistry, earth science, and physics. And if I haven't said so for this video, you may need to pause it every now and then just to stop and read, because I am going to go relatively quickly. You can always pause this and read. It helps if you know a lot about these, but it's not essential. Physics seems to be the one that most people struggle with in terms of not having seen physics or forgotten the important part of physics, that sort of thing. They do love their geology, they do love their earth science, but I see plenty of chemistry and biology on the test too. 3 main types of questions. Again, if I go too fast, just pause it and read them. Look it up. That's a big chunk of the test. Can you keep all the data straight in your head? I'm looking at chart 1, I'm looking at column B, and then I have to answer the question and how column B relates to, that sort of thing. Why? Why do you think they did this? Hey, we had this experiment where the vegetative cover started to go down and the number of animals started going up. Why do you think this happened? And then you have to read all 4 and make the best decision you can. The animals were eating the vegetative cover. That sounds like a good enough answer. The animals ate something and allowed the sun to come down and it burned off the vegetative cover. Well, that also sounds like a good answer. So on and so on and so on. What if? Can you take a situation and can you extrapolate? Can you interpolate? I'll show you those later. So these are my final thoughts on the test. You don't read the instructions at the beginning. It takes up valuable time, so you want to blow through that. You don't really need to know anything about science. There may be 1 or 2 what I'll call prior knowledge questions on the test, but it's pretty rare. Usually it's more than enough to know excuse me, what is in the passage and just, it's more than enough to just read the passage and not have to know additional information. You're looking at 5 to 6 minutes per passage. It depends on whether it's a 6 passage or 7 passage test. Don't overread. Talk about skimming it. Personally, I have to read for comprehension. I just can't quite read things and say, oh yeah, that made sense even though I don't know what's going on. But if you're reading for total comprehension, you're wasting time because they may not even ask questions about certain charts or certain paragraphs. They're just there to almost distract you. So make sure you have a good night's rest. When older people take this test and, somebody in their 40s steps up and takes the test, they always say the same thing: I'm exhausted. That was really tiring. You want to be able to hit the ground running, get to your test nice and early, have a snack with you, get up, move around on the breaks, drink some water. Don't drink too much water. Make sure you go to the bathroom beforehand, all that stuff. So I like to kick it off with an actual test. And this is a real test. You can see I've copied it. It's a tiny bit blurry. Again, take a second, pause it, read the instructions, read the first passage. I'm just going to blow through the answers because I'm not here to give you time to do that. You have a pause button. So here you go. Here's your charts, all your data. No, there's no more than that. That is called figure 1. So watch out. Notice they put 1 up here, 2 here, and then 3 on the left, 4 on the right. Make sure you're answering the question that's being asked. So which of the following elements emitted X-rays that had the same maximum intensity in both minerals? So this is let's check each one. Ca is low and high. Cross it off the list. Cr is here and here. That looks like a possibility. Fe is up here and down. So no, that's definitely not the case. Cross that off the list. Si is pretty high and up really high over here. Always check your scale. You never know when they'll suddenly, have 2 different scales, and you'll say, oh, they're totally different. And you look and go, no, they're the same, because I didn't realize. So that looks like it's off. It's a good way to answer questions, is cross them all off. According to figure 2, an additional information, what's the order of blah, blah, blah from the element with the lowest relative concentration in mineral 2 to the element with the highest concentration in mineral 2. So make sure you're looking at the right one. So mineral 1 and mineral 2 respectively. So we're looking at the one above it. So we want to go from lowest to highest. So Ca looks like the lowest. Compare Mn, no. C, well, C is pretty low too. A little bit higher than Ca. Hard to tell if C is next or Mn is next. That's kind of a crap question, but hey, that's what they do. And Fe is definitely the highest. So it looks like it's F. Ca, C, Mn, Fe. No, it's either F or G. We've got to think about it. If we go back and look closely, we will see that it's G. That's kind of a tough question. I mean, which is higher? The C. Ca is definitely lowest. The C or the Cr, they look like they're almost identical there. So they've asked a tough question. I'm a little surprised they don't usually put it in a way that is so easy to be confused. Oh, my bad. It's not Cr, it's C and Mn. So that actually makes it a little bit easier. And number 3, the energy of the most intense X-ray emitted by an element is directly related to the atomic number. Atomic number of several of the elements shown in the table below. We put a little arrow here to indicate that it's increasing from low to high, the technique we use. And if an element with an atomic number of 0.2 has been present in mineral 1, the energy of the most intense would have likely been what? So 22 is going to be between Ca and Cr. And the energy, so now you might think intensity and energy are the same thing. No, this is energy down here. This is a classic question looking at confused with, are we talking about top, are we talking about bottom, what's going on? So we're looking for between Ca and Cr. So it looks like it's right in about here. There should be something between 3.5 and 5.2. Hey, there we go, between 3.5 and 5.5. Notice again, that's question 3. Easy to get lost on this. According to figure 1, the maximum intensity of the X-rays emitted by Mg is less than half of what in mineral 1? So intensity, we're back to intensity. And we're talking about Mg, and that's here. It's about, it is less than half the maximum intensity. Looking at Si or O. And fortunately, they only have Si in there. And last but not least, suppose another mineral had the chemical formula MnSiO2. Based on figures 1 and 2, would produce 3 maximum intensity peaks where? So we got to go find MnSi and O2. I'm just going to work on this one. It's easy. So we'll have one at like 5.9. MnSi, one at like 1.9. And O2, one at like 0 point something. 7. Now, are they in order? 0.5, 1.9, 5.9. That looks good. Definitely not the 3. Definitely not the 3. Definitely not the 6. Looks like A. So there it is, an ACT passage. We're going to talk for a moment about some things that pop up on the chart, and then we'll wrap up the video and start up again with experiments, with charts and graphs. That was just a sample one, by the way, in case you're wondering how it ties in with the whole note packet. I like to kick people off where they just actually do some real problems and see how they handle it. Another one that you can pause and look. Here are main types of graphs. A line graph, linear relationship, what would you be asked? A bar chart, people like to compare things this way. Good for non-numerical data. Scatter diagram, which they'll often ask you, what's the trend going on here? Well, it's negative slopes going down to the right. Pie chart causes problems. The pieces of the pie add up to 100% or 360 degrees. Watch out for that. I've seen that cause problems. Other types of graphs, exponential, linear, diminishing. I've seen the logistic ones where they change this from what you would normally expect to something like 10, 100, 1,000, 10,000. So always watch your scale. See what's going on. If there is a key up here, definitely look for the key. So here are some interesting charts and graphs. Passage 1, go ahead and read it, but long story short, I believe they're creating an artificial pond and seeing how the animals show up. So here's their chart as the animals show up. And I just crack up whenever I see this because you got this ant over here, which is a long-toed salamander. You got Dad and Kid at the baseball game, which is an adult amphibian. And you got Candy Stripes, which is a pond scum. Well, don't get hung up. They're going to do stuff to try and throw you off. Just look at it and say, okay, pond scum shows up first, followed by zooplankton, followed by the white water lily. And they show up, and here's when they show up by month and things like that. Okay, I get it. As the pond gets older, more and more advanced animals show up. Makes sense. Now they talk about, I mentioned this a little bit earlier, vegetative cover. As colonization progresses, amphibian larvae gradually displace vegetative cover. In other words, there was a lot of vegetative cover early on, like 100%. Wait, no, that's something else. Percent. I feel like I'm looking at this wrong. Age of pond as it gets older. Yeah, this is the vegetative cover. Got to go read the key like I told you. So it starts up really high. It didn't even give you a number. And then it starts dropping off as the number of tadpoles starts picking up. So they're obviously eating the vegetative cover. Here's some more data for this. Somebody put together an insanely complicated graph. The key here is to look at the key. So we'll ask a question. How many Pacific tree frogs live 1,000 meters, feet, whatever that is, away from the water body? Well, it turns out everyone's worth 25, so that would be 100. And a lot of people don't quite get that. They'll say, no, there's 4 of them. Just check out your key and watch out. Here's more graphs. Something about sunburn. Longer in the sun, the more sunburn you get. Get redness, pain, blistering, and then peeling skin. This is the time past exposure, and this is the amount of exposure. So they've got complicated graphs. I'm not going to go into these in great detail. And then it talks about the incidence of melanoma basically going on. And if you've had a sunburn before, actually, let's read it if you want. If you've had a sunburn before, your odds of getting skin cancer are much higher than if you hadn't gotten a serious sunburn before. I think I had several when I was younger, but hey, hopefully not. And this is how we'll wrap up the charts and graphs. Hit all these high points before. Make sure you're looking at your units. Make sure you're looking at your scales. Make sure you're looking at your keys. Make sure you know in the warm-up, the first problem we did, intensity was on the vertical axis, and then something else is on the horizontal axis, and they're different even though they sound the same, intensity and energy. Watch out, watch out, watch out, watch out. That's what they do. These are common units you'll see: liters and milliliters, grams, kilograms, so on and so on. So just be prepared for them all. When we come back, we will start on charts and graphs and do some example problems, and then we'll actually do experiments and go forward from there. Thanks for listening.